Good morning, everybody. My name is Gerald Mills, and I organise this session along with my colleague Jason Ching. And the session is on WUDAT, the World Urban Database Access Portal Tools. Although the major focus on what's going to be presented today is on local climate zones, WUDAT ambitions are much bigger than that, about generating data on cities that can be used by climate scientists to model, to measure, etc. We dedicated this session to Johan Fedderman, who I knew for a number of years. Johan passed away, unfortunately, last year, actually, almost 2 years, of stomach cancer. He was a nice guy. I liked him a lot. And he didn't do a lot of his work inside urban climate until toward the very end, where he undertook land cover change, which was his major interest, and took it upon himself to try and urbanize a climate model, a community earth science model. So I think it's a loss, because he's obviously a very engaging character if you ever met him. So we'd just like to dedicate this session to him and his passing. So I'll start. Perhaps you can put up the first slide.
Yep.
Our first presentation is by the person who's actually provided us with the global databases and global climate zones, which is what the introduction is on. Thank you, Matthias.
Thanks, Gerald. I'm really happy to be here. For those who were in New York 5 years ago, I did have a presentation in the WUDAP session towards a global local climate zone map, and then today I'm happy to present the actual map that is out there since 2022.
Oops.
Just waiting for the slide. Do I need a mic?
We do have one.
Do we?
I think it's being taped, so
For the recording?
it's my recorded, sorry.
Okay.
Um,
Does this
so-
help or just for the recording?
So I think the clicker is actually not working very well with the PDF. So feel free to just tell me to advance to the next slide and I can do that for you. I think it's just because it's a PDF.
Okay.
Yeah.
Can people hear back there?
Can you hear me in the back of the room? Yeah, Matt? Okay, thanks. So, a global map of local climate zones. Next slide, please. So the question we ask ourselves, how should we represent our cities in global urban climate science? Next slide, please. So we've done that for a number of years. So if you go back in time, the first products out there, Movies 500, so that's a 500 meter resolution global data set of urban and non-urban land. So it's just binary. We've been improving that over time. So the ones on the right-hand side are more recent products like the global human settlement layer and the global urban footprint. But as you can see, it's just binary. So our cities are 1, everything else is 0, but we have no information whatsoever on the makeup of these cities. Next slide, please. And there have been many studies recently that identified that it is really helpful to have more information on cities within a modeling context, for example. But I like this one especially. It seems that I don't think the whole slide is actually on the screen, but does it move around? Or?
Yeah.
Doesn't matter, so hopefully. So this is a paper by Denise Hertwig that was published in 2021, and they undertook a modeling study using the UK Global Climate Model over 2 dedicated areas. So the top row, that's London, and then the bottom row, that's the larger region around Shanghai. On the left-hand side, you see the representation of the global urban footprint that reflects reality as is, still binary, but still you can see where the cities are. And then on the right-hand side is a representation of the cities within the modeling context. So this is what the model knows. For London, it's not too bad. The city is there, it exists. For the Shanghai area, that's a completely different picture. So most of the city just doesn't exist. So as you can imagine, next slide please, that has a lot of consequences. So there are key findings of the paper was, first of all, naturally, that the representation of urban land cover is identified as a primary source of bias, which makes sense because the city was just non-existent. That, of course, has other consequences in terms of the representation of anthropogenic emissions of heat and water. And then they also identify that the urban scheme that they use within the study is a bulk model that just has fixed parameters for every urban pixel, so that doesn't vary in space. And so also that is a strong limitation. So all of these things we try to address. And that is basically why Jason, next slide please. Jason and a lot of other colleagues came up with WUDAT, the World Urban Database and Access Portal tools, which is really a community effort to provide urban canopy information and modeling infrastructure for a whole range of applications as listed there. So for those who don't know about this paper, it's available in BAMS 2018, so I think it's pertinent to get a bit of a sense and overview of what the intention is. Next slide, please. So within WUDAT, there's 3 levels of detail. There's level 0, 1, and 2. You can see, so it's a bit of a busy table, but the levels differ in terms of resolution, in terms of what they represent, and also in terms of the data that goes in order to represent all these features. And here I will mainly focus on level 0. Next slide, please, which are the local climate zone maps. Next. I hope this is how I always tell the story. So Iain, you have to correct me if this is not right. But so basically, Iain undertook a big review study in 2011 in which he revised 190 papers on urban heat island studies and concluded that 75% of these papers didn't have any information or any metadata on the instrumentation and field site characteristics, which is really crucial to understand the thermal property of actually what you measure at that site. So because of this, he came up with a rather simple scheme that combines height, density, land cover, and thermal properties, which are then put into 17, next slide please, local climate zones, 10 of which reflect build types, and there are 7 others that reflect natural types. Next slide please. And that was Benjamin who started this mapping procedure. Initially, so the whole idea of the mapping was to come up with a method that is universal, simple, and open access. So the idea was that you get relevant Landsat tiles from the USGS database, you create your training areas in Google Earth, and then you use the local climate zone random forest tool within the open source Saga JS software to come up with your local climate zone map. As this is the example for Berlin. So this was working very well, but it did had some downsides. For example, you had to download all the data. These Landsat tiles are pretty big. There was no automated quality control, and there was the community itself did not have a lot of resources to actually make these maps available to the wider community. Next slide, please. So because of these limitations, I started to update the procedure. So the input information was taken directly from Google Earth Engine, allowing us to not only use Landsat information but also other sensors, from, for example, Sentinel-1 and Sentinel-2. The digitization of the training areas was still done in Google Earth, and then the mapping itself was also done in Earth Engine a number of times. So I use a bootstrapping procedure, which allows you to assess the quality of the map. So this was all set up automatically. Next slide, please. And that allowed me to create, first of all, European map, and then I went over to the continental United States. Next slide, please. And so at that point, we're like, okay, there's 2 things here. We should try to go for a global LCZ map, but at the same time, we want to make sure that the community has access to the procedure to move away from this initial scheme as it was devised. So this is what was in place originally within the WUDAT context. It's again a dense diagram, but it just indicates, in my opinion, 3 bottlenecks in order to make the information available. There was, first of all, those within the community that were making a map did not upload it to the community. So there was just living somewhere locally without access to anybody else. Then At that time, there was a review process in place, but that required a manual review. And that was needing a lot of resources, which were not really available. So that was also a limitation. Then also the connection to the portal itself was not automated. So all of this had to be done by hand. And at that point, we decided, okay, maybe we should use we should implement what we use for the large scale maps into a new system, and that's when we came up with the generator. Next slide, please. So this tool has been online for like 2.5 years, I think now. It's rather simple, so you just need to provide some user input. All processing is done in the backend, so everything is done on Google Earth Engine, including the 25 bootstraps, the accuracy assessment, as well as the identification of suspicious labels within your training area. So this is also sent to a user to give feedback, allowing a user to revise the training labels and then resubmit them again to the generator. Next slide, please. So this is how it looks like if you go to the website. Next. And at the same time, we can provide all LCZ maps to the community. So all of this is freely available. You can see the submissions. I took this screenshot in July. I think by now we have over 6,000 entries, which is not too bad in 2.5 years. So the system is up and running, is well used, and you can see that people do resubmit their initial version to try to come up with a better map. So that works very well. Next one, please. And because of the system, we also had access to a lot of more training areas, which we didn't have before, because they did exist, but they were just not available to us. But now we have, and because of this, we were able to train a classifier that was actually better representing the global scale. So this is a quick summary of how I've done this for the global map. So I've done a lot of local work, on a local machine, to understand the number of features that were important, how to use the features in space and time. So that was the beginning, and then I moved everything to Earth Engine again to do a number of maps. So in total, I did 50 maps. The resulting map that you all have access to is the mode of these 50 maps. And this map also contains a probability layer. This is not the probability for a label, for a pixel to be a certain LCZ. It is the probability of the mapping procedure, so of the random forest. For example, if out of the 50 maps, 30 maps represent a pixel as an LCZ, then the probability will indicate 60%. It's just a measure of consistency between the different random forest results. Next one. So that's the map. It's all available. The paper is open access, and the data is available on the Nodal, also in Earth Engine. Next one, please. And now finally we get a better sense of how our urban areas look like. So on the left-hand side you see again the binary global urban footprints at very high resolution, and on the right-hand side representation of the larger New York area as it is in the global LCZ map. Next one. Here there's a slide missing, so the idea was to first show the table, because Iain came up with all these parameters that are linked to all the LCZ labels, which you can then use in your, for example, in the modeling context. So typically we work with either the mean or the median of the range that is provided, but as a user you can always try to come up with values that are more representative for your specific area, if that is needed. So the way we describe it in the paper is that the global LCZ map describes all the cities of the world in the same universal language, but interested users can read it in their own dialect. Next one, please. So for those who do not know this, there's a WoodUp website, woodup.org. There's a menu LCZ maps. Within that menu, they have the overview of all available LCZ maps. So there's the generator maps, the global maps, and then the continental maps. Next one. But the website also hosts a section on tools, like how to generate the LCZ map, but also how to use the WoodUp data into the models. Next. Next. So in that section, there's lots of things ongoing. So there is the UDAP to WRF tool that is available, that is also well used. But at the same time, for those who attended Jen's presentation, we've been working on implementing this integration of LCZs and WRF in the WPS system. So as user, you will no longer need an external tool. I'm also working with things soon and MATLAB to work with LCZ in the SUSE model. There's work being done of using LCZs in the global Earth system model. And I also wrote a UDAP to Cosmo converter tool to use LCZs in Cosmo and Cosmo CLM. But also there's a person at Meteor Swiss that is currently making this procedure available within XPAR, which is like the preprocessor of the Cosmo CLM model. So all of that is ongoing. There's probably many more things that I don't know of. If there is anything you would like to see listed on the website here, you can just reach out to me. Because there are also some other links on how to generate urban canopy parameters. So there are lots of tools nowadays that can help you doing all this work. Next. Okay. Was that 1 minute? Well, then I will stop here. So this is the conclusion. I mean, I think it's a good step forward having this global map, but I don't see it as a holy grail. And people always come up to me like, yeah, I've been using the local climate zone map, but for my region it doesn't work very well. But often these are also people that have access to better data. So I always try to say to people that if it works for you, use the local climate zones. But if you have any data available that is providing you the information on the urban landscape in much more detail, then please use that. I mean, there's no point in using LCZs to have like a kind of first order approximation if you have the data. So that's always just maybe the take home message of this talk in the end. And I will stop here.
Time for just one question, I'm afraid. Stand up and introduce yourself.
Okay, my name is Benjamin from Universiteit. Thank you very much for your presentation. I want to ask you a question. I'm wondering how you get the training areas for the global map. And the second question.
One question. And then one question. So you can follow up on that. But the first question, ask that one.
So sorry, the second one is my point. Yeah.
I have to keep on time, Benjamin. Ask one question.
Yeah, I am wondering how you need generated local climate zone map on the NCZ generator, because for the moment, no option is not, right?
So what option is not available?
Yeah, how we can delete maybe NCZ map generated using the NCZ generator. How we can
You want to delete the submission?
Previous version. If you have like 10 versions,
yeah, if you
because you are
have
trying
10
to
versions, how we can delete one.
At the moment, this is not possible indeed. But that's part of the system. I mean, it has always been designed as an iterative process. So I'm not sure. I mean, we can talk about this separately. For me to understand why you would like to do this, because I mean, I don't think it's wrong to have maybe not so good submissions on the system. That's fine. But so short answer is this is not possible at the moment.
In any case, you'd hardly be deleting somebody else's work, would you? So that's an ethical issue also, I'd imagine. Now, I'm sorry, but because of the limitations, I'm going to move on to the next speaker. About 10 years ago, in fact, just over 10 years ago, at ICUC8 was when this project formally was initiated. And the person who was responsible for the ubiquitous use of local climate zones that you see at this conference